Hello, Techie Dheeraj here. Today's topic of discussion is Dockers. Title of this tutorial is Docker Concepts and Introduction in Practical Way. Level of this tutorial is intermediate and I am assuming you have already installed Docker in your system. If you have not, please go through the links provided in the description. So without wasting any time, let's go ahead. So what is Docker? Docker is basically a computer program that performs the operating system level virtualization, also known as containerization. Docker is very popular tool which makes it easier to build, deploy and run our applications using containers. Containers basically allow us to package all the things that our application needs basically like libraries and other dependencies and put that all together into a package, and that packaged form is called Docker image. Docker container is a running instance of that image. Docker container does not require any separate operating system. It basically runs with the isolation of CPU and memory and in separate namespace as our host namespace. VM versus container. As you can see in this picture, left side is the VM. VM basically VMware or virtual box, and the right side is the containerization. In the left side there will be a host operating system, and above that there will be hypervisor, and we can install our guest operating system. Inside guest operating system we can run our app, and all the binaries and libraries will be there to support our app. Hypervisor basically deals with all the system calls, all the resources you require from the host operating system. In the right side, containers. Containers basically are isolated but share OS and where appropriate means libraries. So as you can see, host operating system, above host operating system there will be Docker engine which takes care of all the system calls, and all the resource management need to be done over the containers. As these apps, we can run all these apps in a separate containers. So let's go ahead with some practical explanation. Okay, so this is the Docker client which we which talks with our Docker engine. I think, yeah. So this is our Docker concept. As you can see, client, REST API and server Docker daemon will be there. So this daemon basically listens over a socket, which is a Unix socket using the REST APIs, and client, whatever like we need to call, like start a container, stop a container, remove a container, everything needs to, that call needs to go to the socket, through the socket to the server. So that is based on the REST APIs. Okay, so this is our client. So these are the management commands basically. So like Docker container, Docker engine, Docker image. So these are the commands. So management commands, after management commands we can run our normal commands like docker config, docker attach, docker engine, docker commit. So these are the first command, and in the following commands we can run these all commands. So like docker, so this is the basically Docker images table, where whenever we pull some image, all the images will be listed here. Like currently there is no image, so this table is empty. So going through with our practical explanation, I will just pull a hello world image from the repository, and the repository by default, Docker is using a Docker hub. So it will try to pull the latest hello world image and will try to run that. So Docker pull hello world. So this is using the latest tag. So let tag means like we can have multiple versions with the image. So this will try to pull the latest uploaded image there. Now if I do docker images, you can see one entry is there, hello world. It's pulled from hello world repository and tag is latest. This is the image id. Okay, so if I want to run this docker run hello world. Okay, so as you can see, this has been succeeded. So it's showing hello from Docker. This message shows that your installation appears to be working correctly. So this container image is basically just to test our environment whether Docker is properly installed or not. So some basic commands I will show here, like Docker PS. Docker PS basically shows the running containers. Whenever I start a container, it will be listed here because I started this container hello world uh, as it started, and it immediately exits, so that's why it's not showing here. But if I do ps-a, it will show like this: the image hello world was started created 53 seconds ago and was exited 52 seconds ago after printing that name. Okay, so docker ps is running thing. Docker images is our images history. So docker network ls. So this basically table will show our all the networks whatever we created, like bridge network, like that container. If some container is running in bridged with the our host, that will be shown here. This is a volume directory, volume uh, table basically. So this will show like whatever the volumes are inside uh, dockers, like I will explain in the future. So with our explanation, let's pull an nginx image. Okay, so there is follow up is docker events. So docker events is basically nothing. Whenever I pull some image, as I explained earlier, whenever I run docker client, the all the call goes to the uh, our docker daemon, docker engine. So that will take care of all of that call, and all that communication happens through the socket, and that socket is this is our socket. All the communication happens through this socket. And docker, if I so this is our docker daemon running. Oh, currently I mean they are using this socket actually. Yeah, so this is our socket basically. Yeah, this is our socket. They're using this socket to listen all the calls coming through the docker client. So I will pull one image, docker pull image pull nginx. Okay, I will show one more way to pull the image. Like in the earlier, I pulled the hello world image, as you can see here. But for this, I will not pull it. I will just directly run it. So Docker basically has intelligence. Like whenever I am starting this, I'm running this image, and that image is not here in my local repository. So what it will try to do, it will try to pull that image from the server, from our docker hub repository, and then try to run it. Okay, unable to find nginx latest locally, so it will try to pull from the, like as you can see, it's downloading. It's of size some 23 MB, so it will not take much time. uh, I think my internet is a bit slow. Let's, yeah, it's downloading. It's a 109 MB. Okay, yeah, it started also. It's running. Oh, actually, this is a hang because I ran the docker run command, and I, there is one problem with this basic command. I will explain now. Okay, I will cut this. Yeah, it's also. So the problem is whenever I run directly docker run some image, so it will take that current session and hangs over there. So if I want to uh, if I don't want to that happen, so what will I do? Docker run -g. D is for detached mode. It will detach this session and will run this in the background. T T is for uh, telling our Docker daemon to give me a TTY session to execute further commands. Yeah. So as you can see, I just started Docker run Nginx. So if you see here, Nginx is up and running. As you can see in this output, Docker PS. So everything is up and running. This is our container ID. So all the containers will be identified by this unique ID. So if I run it again, for example, I run it again, so there will be new container running. As you can see, two containers are running. So this is our full, basically, unique ID which identifies the particular container. Okay, so how do I enter into this container? So there are two ways to enter. One is if you have SSH service, secure shell running inside container, then you can log into SSH. Okay, the other way is we can use the docker command. So docker command, docker exec. Exec means we want to execute something inside docker. So we pick the client ID, container ID, and docker exec hyphen it. It basically what I does, I basically does the stdn std in for the container. It will log in through the interactive mode, and we will provide the. So what this bash does, basically, whenever I do exec, so we can execute some commands inside this container. When I will do bash, it will give me bash shell of that container. Right, as you can see, I got the bash shell of the container. Okay, so this is our, there will be nothing, it's a very basic image. It contains very like common commands and binaries. So we will exit through it. Okay, so as you can see, I just ran a Docker container. Now we can stop this. Docker stop. I stopped it, and other one also. Okay, as you can see, there is no container running. So how to test this, basically? So when, if I want to send some traffic, some network traffic to this container, I have to expose of port of that container inside my host machine. That is one way. The other way is I have to find the network what whichever my container is using. Okay, so I will run it again, but this time I will open a Docker events. So what is Docker events? So Docker events basically listens to all the communication happening with our Docker engine. So when I execute Docker events and I run this here, so you will be able to see what communication happened between Docker's client and Docker daemon. As you can see, it's asking for container create and then network connect. So it's creating a bridge type. Network type is bridge. And now the next command is container start. Okay. So this is a container Nginx server up and running. The problem with this is listening, this container is listening over 80 port, but how can I reach this container? This is in type bridge. So this is in some different network. So I have to find out which network this container is in. So there is one command docker container inspect. So yeah, so if I enter into this, so as you can see, after inspecting, it will inspect about Docker, this running container, and will give all the informations. Okay, so this is our unique. This is a short ID, but this is a very unique ID across all the containers. So whatever the commands passed while running the container by Docker daemon is this nginx and -g daemon off. So as you can see here also, this command has been passed while the running this container. State basically shows the current state of this container. It's in running state, so it's showing status as running. So I will explain the basic thing like yeah. So this is our host name path. As you can see, where lib docker containers this is our this containers directory. So what this directory basically, whatever we are going to write over to this, and this whatever going to store there inside this, that all content of the container will be stored in this directory where lib docker containers. I will explain this further later. So these are the capabilities of the container, like capability add, and it currently is using the default, so it's not using any capabilities like PID mode and C groups. We can do lot of things with Dockers like IPC mode. Yeah, CPU shares, memory, nano CPUs. Like we can tell this Docker engine to give two CPUs to this particular container, so we can edit this whole information. Some IO, maximum minimum IOs, we can like we can tell our Docker engine to whatever we want to do with this Docker over the IO operation. Yeah, so I was looking about this one. So this is our network settings. Inside network setting, you will be yeah, able to see the gateway and IP address. So from this we can find out the our server's IP address, on which Nginx is running. So this is our containers IP, and gateway is our basically host system's IP. If I When I install the Docker in our host machine, so there will be a Docker 0 virtual interface will be created, which is basically a tunnel with the container. So if I do this, as you can see, this is also the same IP. That interface is created between one. So all the traffic which goes to the containers, that will go through this virtual interface. So as this is the gateway of that container. So container's IP is 1702 as this is in the bridged mode. So I will try to reach to this because as just I started Nginx server, so I hope Nginx server is up and running. I will just start. I will just check whether Nginx is running or not. Yeah, welcome to Nginx. As you can see, this is the web page hosted by Nginx. So it means it's up and running. But the problem is this I'm able to reach through only my machine. If I want to reach from other system to this Nginx server, how can I reach? That is not possible. That is not fully explained here. So what we need to do, yeah. So as you can see, currently it's listening on 80 port. So what we need to do, we need to expose a port of my host machine and link that port with the Nginx port. Then I will, if I reach my system's port, then it will forward all the traffic to the Nginx port. So we will try to do that. For that, I have to stop this running container. Okay, so I will just run it again, but this time I will run with one hyphen p flag. So what is this? This is a basically port mapping flag where we map our host port. For example, I'm mapping with our my 8086 port. So I'm opening a 8086 port in my host machine that will forward all the traffic to the 80 port of my container Nginx. Okay, so I will just run this. Okay, as you can see now, its port is open now. Now I don't need to go to this IP. I can just do localhost and 8086. If I reach this port, it will also go to. I will open it again. This, as you can see, Nginx is up and running. I am able to reach that through the 8086 port of my machine. Okay, so the one way I want to explain more is okay. So as we did this, so as you can see, there is a lot of information coming along with my required information. So we can format this information. Like I just want the IP address. Okay, so for the IP address, I just need to go to the network settings. So there is a flag called format. So in the format, if I do network settings and then if I do, okay, let me try this. Yeah, if I do inside network setting flag, there is a IP address. So by running this, I can directly find out this IP. I don't need to go through all the information and filter out whatever I need. So I can just directly pass that particular field from this by using this hyphen hyphen format option. Okay, moving out to our list. So as this list is basically completed, inspect container and print IP address. So I want to add one more thing here. Okay, so the thing basically I want to add is I want to pull an Ubuntu image here. Docker pull. Okay, I will try the other way. Docker run Ubuntu. So it will do again. Okay, I think the base image was already there. No, it is pulling it. Pull the image from. Okay, so Ubuntu image is there. Yeah, so I want to explain one more thing here. Like we have seen this, I think it will not work. So yeah, so okay, I will explain that. So as you can see, we have reached this stage, but there is one more thing like volumes. So we can, as you can know, like whatever I will create inside Docker will be washed out when I shut down or exit from that Docker. I will explain that. Okay, so we have Nginx running. If I go to this, I have created a hello directory. Okay, so I have created a hello file, and I have added a word string inside hello file. Okay, if I exit from this container, I mean this is running in detached mode, so this will not affect this container. But if I exit, and before explaining the exit thing, I want to explain, like I have created a hello file, and inside hello file I added a string world. So there is one command docker diff. Using this we can check docker container diff, so we can find out whatever the changes we made inside that image. So as you can see, this diff basically takes the difference with the image. Okay, so that's why you are seeing this where cache nginx and all these files are added, because while starting the nginx uh, service, so it created some temporary files in where cache. But in our scenario, see, so here you can see, like I created one file in slash root hello, so this is showing here slash root hello, and it's also penned in bash history because I ran some commands echo and cat, so bash history was also changed. Okay, so C is basically showing which directory was changed. Okay, so okay, if I stop this container docker stop. Okay, if I, as this container is stopped now, so whatever we uh, created this file and all is deleted now. Okay, so the data inside container is not persisting. Like even if we run it in detached mode, somehow if docker container got killed, so whatever we created inside docker will be gone. So to prevent from that, we can mount some volume from our host machine to the docker container. So how we do that? So we have Ubuntu image pulled out. So this is our basically hyphen v. So this is hyphen v flag. So hyphen v option basically tells the Docker engine to mount particular directory inside container to that particular path. So like for example, I want to mount my temp directory inside media of the container. The right part of this column is the where you want to mount inside container, and left path is the source path, which directory you want to mount. Okay, so I will just give the name. Yeah, it should work. Yeah, it is working. So as you can see, and I exposed that 86 photo as well. So as you can see, if I go, yeah, as you can see here, I mounted the directory to slash media. That's why you are able to see in this mount uh, command, like this is same as this one. Here you will also be able to see that. Okay, there are low, yeah, here you can see media. Okay, if I go to media, currently actually there is nothing in my time directory, so I will explain. As yeah, this was also running Docker event, so there is a lot of things happened, like I stopped the container and all those things. I just started the uh, Docker start and this container start, exec start, so all these things were running. So I will do one thing, touch testing volume. I created this directory here in my host machine. If I go to this machine, this should have been there. Okay, let me check that once again. What I ran? Sorry. I actually ran the home temp directory. Okay, so by default, I don't think it's temp. So I will create temp to my home. So it is there. So I will create this. Sorry, why is this happening? I don't know why this is asking for permission. Okay, so I gave anyway root. I don't know. Should be asking root. If I go through the container again, yeah, as you can see, testing volumes is there. Okay, we will exercise this again. It should not be asking root. I'm just going to test that. Let me just see. Oh, it was asking because it was created root. Actually, that directory was not there when I started the container because I gave the temp path to the hyphen v option. That's why it created a directory on the fly. So I will just delete this. Okay, now if I create, now it's on my username. So now if I, so this I will move to 10 directory. As you can see, it's here. We go hello world. I copied that to the testing file. This is my home directory. So now I will run that command again instead of, yeah, I will run this again. So there is one more thing I want to explain. Like in the PSS container ID, if your ID is unique, like some like 4 5 containers are running and all starting from 6C to D, then you have to carefully give the full or unique till the unique part container ID. It's very in this Docker CLI is very intelligent. If even if I give these three parameters or two parameters, it will understand which container I want to go. As you can see, if I see, yeah, it's running fine. Hello world is there, so we don't require any root permission. Okay, so I think this is it for today. I hope you enjoyed the video till now. Please don't forget to like, share and subscribe to my YouTube channel. Till the next tutorial, I bid you farewell. Thank you.